welcome again, everyone, to the training. First, I will give an introduction. We'll talk about evidence-based policymaking to give a bit of context. I'll give a tour, introduction to SciVal and the key functions, and then we will do a hands-on training where you get to try different things using SciVal and ask questions. So first of all, in introduction, so KMITL subscribes to SciVal, which is a research analytics platform built by Elsevier. And it is really a tool to help universities, governments, faculties to make decisions about research strategy and to try and efficiently invest their resources and get the best outcome possible with the resources that you have. So some of the key use cases are to identify key strengths and weaknesses of the university or country or faculty or individual, to do evaluation like benchmarking. Performance is not an absolute measure. It makes sense to measure yourself compared to other people or compared to other faculties or compared to other universities. The tool can be used to set and measure key performance indicators. So for example, if you wish to encourage your researchers to publish in top quartile journals, you can use SciVal to see how many papers each individual or each department has published in the top quartile journals, or there are many other indicators which you can use. SciVal is also used for collaboration to understand who works together, which networks underlie high quality research, and who could you work together with to improve quality. It's used for talent recruitment and to identify top researchers in particular subject areas to ask them to come and work at the university or maybe just to collaborate with them. And it has also been used to support some grant applications by demonstrating strength in particular research fields. The data in SciVal, most of it comes from Scopus, but it also has patent citation data from the major patent offices and mass media information from Newsflow. So patent citation information are show how many times a scientific paper has been cited by a patent. So if I write a scientific paper and let's say I have 10 citations from other scientific papers, that's like citation impact or impact on academic, my impact on other academics. But if there are patents which have been filed that in the references of those patents they cite my paper, then that's a patent citation and it says something about the contribution of my paper towards the innovation process. So that's an important metric that we've added. Scopus is a good data source for this type of big data analytics because it's incredibly broad and comprehensive, covering more than 24,000 journals in 40 different languages. And we did a project with TCI and TRF to add almost 40 new journals in the last 3 years. So we have more than doubled the number of Thai journals in Scopus during the last 3 years, which are also represented in SciVal. Currently, SciVal is being used by these institutions in Southeast Asia. So you can see that they include government organizations like the Ministry of Education in Malaysia or National Research Foundation in Singapore, but also some of the big universities like National University of Singapore, Mahidol, Chulalongkorn, KMUTT, NSTDA, and now also KMITL. So that's nice. The subscription includes consultancy. So I'm the dedicated consultant. My name's Alexander. I've been working for Elsevier for about 14 years, and I've been based in Singapore for 7 years. In Thailand, we have many universities using SciVal, so I come to Thailand normally about once a month. So I've been to Thailand, let's see, once a month for 7 years. It's a lot of visits to Thailand, and still my Thai not very good, so I'm speaking English, but I hope that I can learn some Thai one day. But what I would like to do with you is to help you understand which information in SciVal can help you to make better decisions and help you to make a strategy, to help you to refine your research strategy at the central level as well as at the faculty level, so that it can benefit from quantitative data combined with, say, the qualitative inputs of the people to create a strategy, which is what evidence-based policy making is that when policies, whether it's a government or a university, if you would go back in time, a lot of policies have been based on expert opinion, qualitative inputs from people who say, well, I think we're very good at engineering, or I think we're very good at at tropical medicine. But expert opinion, as valuable as it is still subjective, and it is a stronger case if you can combine qualitative expert opinion with quantitative data, such as the analytics that are in SciVal. So that way you combine expert opinion with the quantitative data to form or triangulate to form a strategy for planning research. This helps with regard to justifying decisions, because you can very clearly show the evidence for why certain decisions are being made, as well as tracking the change in performance. So if you were to make a decision today, you could track the data and see what differences you see in research output, volume, and quality and impact over the next few years as a result of the change in policy. Some of the key questions that SciVal and research metrics in general can help to answer are: how much world-class research do we publish, and what's the quality and trend? So based on SciVal, I see KMITL produced 4,820 papers between 2014 and 2019. And those papers were cited 12,232 times. So the question of is that a lot of citations or is it a little? So we can see it's 2.5 citations per paper as an average. But if you were to look compared to world average, the field-weighted citation impact is 0.6. The world average field-weighted citation impact is 1.00. So 0.6 is 40% less citations than world average. So the metric field-weighted citation impact makes it easy to interpret the number of citations that are being received by any university or department or person or country and so forth. if we look at a number of key indicators over a 6-year period, we can see that the number of papers have grown quite a lot from 2016 to 2018. But we see, if we look at the percentage of papers that were published in the top journals, so let's say the top 10% highest quality journals, decreased a bit from 2016 to 2018 and then increased again in 2019. In terms of the percentage of papers which were very highly cited, we see some fluctuations. So we see that it went up from 2016 to 17, down in 2018. Seems to have gone up in 2019 again, but for a citation measure, you should wait a little bit longer before making a conclusion about the year 2019, because it takes time for papers to receive citations. Field-weighted citation impact, we see a trend where, well, the impact of the university is below world average. So that's the first thing. It would be good to probably get more citations. Trend is fluctuating a little bit. I see a bit of a decline from 2016 to 2018, which is worth trying to understand in a bit more detail. How do we compare to others? So whether you are a person, department, faculty, or university, it makes sense to compare to others to get a sense of how we're doing. And I chose a couple of universities, 3 other Thai universities, and 1 small Singaporean university. So here we see the orange line is the number of papers for KMITL. You see very strong growth from 2016 to 2018. We see that Khon Kien and Kazetsart produce similar numbers of papers, produce a little bit more than KMITL, while the Singapore University of Technology and Design, they really went from almost no papers in 2010, like really like 20 papers or something, to having almost as many papers as KMITL in 2019. When we look only at articles and reviews, so this means excluding conference proceedings, we see that KMITL is producing a little bit less than some of the others. So the difference between Khon Kien, Kazetsart, and KMITL is bigger. This may be because as a university that's focused a lot on engineering and computer science, you may publish a lot in conference proceedings, but I think that Kazetsart also is quite active in engineering. Although they might do more in agriculture. If we look at all papers published in top quartile journals, so here I used CiteScore, so we're looking at the number of papers published in the top 25% highest quality journals, and you see what stands out is that actually in 2019 it was the Singapore University of Technology and Design published the most papers in top quality journals. After that, we see Khon Kien, Kazetsart, KMUTT, and you see here at the bottom is KMITL. So actually you're not targeting or not managing to publish high numbers of papers in the top quality journals compared to some of these other universities. If we look in terms of field-weighted citation impact, SUTD really stands out. Their papers are cited much more than world average. The world average is 1. But these are trends and metrics which are based on all of your content. And the next step would be to understand what are the strengths and weaknesses and who are the people and departments which underlie the key research strengths. So if we look at a subject level, subject area level. So these are 27 main subject areas in SciVal and Scopus. So you can see you publish the most papers in engineering, computer science, and material science. But the citation impact is below world average. If you look at chemical engineering, you see that the citation impact is getting close to world average. That's good. Also, earth and planetary sciences, it's close to world average. And in veterinary science, it's only like a few papers, but the impact is like 20% more citations than world average. If we look at a discipline level, so the subject areas are 27 subject areas, and within the subject areas, we have 330 disciplines. And there are a number of disciplines in which KMITL shows a lot of output, and in some of them, the impact is very high. So some key pockets of excellence are mechanical engineering, industrial and manufacturing engineering, biochemistry, the 9% more citations than world average, horticulture, 77% more citations than world average, fluid flow and transfer processes, 25% more citations than world average, fuel technology, 32% more citations than world average. So these are a number of disciplines in which your papers are relatively highly cited. If we look at the strength in mechanical engineering, that is driven by the following researchers. So we can see for each researcher in mechanical engineering how many papers they've published and what the citation impact is. So we see that Naratip Vidyakorn has 9 papers which were cited, 19% more than world average. So this particular researcher has a higher impact than some of the other researchers, specifically within mechanical engineering. Which prominent research topics are we very active in? Research topics is even more specific. So we started by looking at everything, and then we went to looking at 27 subject areas to looking at 330 disciplines. The topics are 95,000 topics. So this is the most granular or specific level that you can look at. And we see that KMITL is active in a lot of topics. But if we look at topics in which KMITL produced, is a key contributor and producing high impact research. So the slide is a little bit blurry, my apologies, but if you look at, for example, heat transfer tube components and tube inserts, it's 63 papers, which were cited 64% more than world average. And you produced more than 5% of the whole world's research in this topic. Where the bottom one, operational amplifiers, capacitive load, 25 papers, almost 3% of the world's research and 67% more citations than world average. If we look at this topic, amplifiers, KMITL is the #1 research university in the whole world, producing 182 papers in this area. But those papers are cited 22% less than world average, while the Borneo University of Technology, their papers are cited 42% more than world average, and JP University of Information Technology also has papers in this area that are cited more than world average. So that my question, are there researchers there that you should be working with? Is there partnership that you could make with those universities that will help you to raise your citation impact in this very specific research topic? So the next step is to kind of do some faculty level analysis. So here the question is, how does the research performance of our faculties look? And here I'm looking at only 3 faculties, the Faculty of Engineering, Faculty of Science, and College of Nanotechnology. So you can see that the Faculty of Engineering is producing the most papers, followed by Faculty of Science, and the College of Nanotechnology is a unit which is producing lower numbers of papers. Now, if we look at the number of papers published in the top quartile journals, we see the Faculty of Engineering has over 45 papers per year in the top quartile journals. And in terms of field-weighted citation impact, actually in the last 3 years is the College of Nanotechnology, which has the higher citation impact than Faculty of Engineering and Science. So another thing you might question that comes to mind is, how does our faculty or college compare to a different faculty at a different university? So in this case, how does our College of Nanotechnology compare to the University Malaysia Perlis Institute of Nano-Electronic Engineering? So I did this quickly this morning, and we see that in terms of number of papers, the Institute of Nano-Electronic Engineering, they seem, maybe they closed down or they not so active anymore, but they went from 55 papers in 2017 to less than 10 papers last year. So your College of Nanotechnology surpassed the number of papers of this particular institute in 2015 already. So what type of hot topics does the College of Nanotechnology publish in? So this is looking specifically at your KMITL College of Nanotechnology, and we see that your college is represented by grouping together 25 researchers who in 5 years produced 270 papers. And we see that the top 5 topics are zinc oxide, nanorods, seed layers, nanoparticles, plant seedling growth. And the bottom 2, you can see I circled because the citation impact is relatively high. So especially in the topic cadmium telluride and zinc telluride, the 6 papers that the College of Nanotechnology published in that topic have been cited more than 2 times world average. Collaboration. So now moving to look at the Faculty of Engineering, a question might come up: what universities does the Faculty of Engineering collaborate with most? And these are the top 10 universities, so you ignore the top 1 because that's your university, obviously. But especially the collaboration with Manahorn University of Technology, Kazetsart, and BRNO University of Technology, those collaborations resulted in relatively highly cited papers, more than world average. So those are the, let's say, beneficial collaborations which you might want to build further on. While, for example, collaborating with King Mongkut University of Technology in North Bangkok, it's a large number of papers, 102 papers co-authored with Faculty of Engineering, but the citations very low, so 64% less citations than world average.